Hello, welcome to video 1 in a series called Shell Preparation for Sclerochronology. This video series is brought to you by the Stable Isotope Paleoenvironments Research Group at Iowa State University, as well as the National Science Foundation grant number 2303468. Before we get started, I'd like to say thanks to a couple of people, Dr. Alan Wanamaker, Dr. Diana Thatcher, Suzanne Inkerstar, and Amanda Hauser, as well as countless undergraduate researchers and graduate students who have worked in our lab over the years and refined this shell preparation method. So we're going to start at the beginning here. You have in front of you a basket full of Arctica Icelandica, the shells that we commonly use in our lab, but you may have acquired some shells, collected them yourself, dug them up, gone clamming, been given them to you to prepare, and this is where we're going to start. So you've got live shells that have been given to you or that you have collected, and the first thing you're going to want to do is to dissect them. So maybe they have been frozen and you let them thaw a bit and then dissect them, or possibly you have dissected them before they were frozen at all. With those tissues, there's a number of things that you could do, and that depends on your interests. One of them could be to determine whether the clam was male or female. You might be interested in some of the tissues. That's a subject for another video. So you'll go ahead and dissect the clams. You'll rinse the shell in deionized water and allow them to dry. After doing so, you'll want to label each shell, so both halves of the shell, with the name of the shell and whether it is the left or right, and we'll talk about how you determine that in a moment. And then you'll go ahead and collect some measurements on each of these shells, which we'll talk about on the next slide. The measurements that you're going to be interested in include the following. So we're looking at both of them from the inside of the shell and the outside of the shell. You're going to want to collect the height, the length, and the maximum height. And the maximum height you can see kind of spans across the shell from the hinge to the outer margin. And you'll want to keep these all in a spreadsheet, and the next slide here will show you what that spreadsheet looks like in our lab. This is a spreadsheet where we keep track of all the details of the shells. So when they were collected, who collected them, the boat, the depth at which they were collected, as well as the latitude and longitude, and then those measurements that we talked about before, the length, the height, the maximum height, as well as the mass of one of the valves. You can also keep track of some details as to the condition of the shell itself, the condition of the periostracum, and any other important variables that you think would be useful information going forward. Once you've measured all the shells and you dried them and cleaned them and dissected them, then you're going to want to make labels to go along with each shell, which include some of these important details as we've done before: the measurements, the latitude, longitude, the depth, the date of collection, the name of the shell, etc. And the way we do it is we kind of bag everything up. So the bag is labeled with the name of the shell. All the parts of the shell are inside of the bag, as well as these labels. And as we process them, the various components, including the blocks that we're going to create here, are going to be contained within this bag. So everything for one shell is going to be in one bag with a really good label on the outside, as well as identifying information contained on a slip of paper on the inside. This image that you see here from the University of Kentucky shows various parts of the shell. For our purposes, we're going to look most carefully at the left valve and right valve and the way that you determine that. So on the left side of the image, you can see the outside of the shell and kind of lining up the hinge to match these images. Then you can determine which shell is the left and the right, or you can look at the inside of the shell and use the right side of this image to help you determine which is the right valve and which is the left valve. And like I said, you'll want to indicate that on the inside of the shell. So the name or the number of the shell, you're going to write in pencil on the inside of the shell, and then -R for right or -L for left. Once you've determined the left and right valve and you've labeled everything accordingly, now we're going to go back to one of the measurements that we took before, where we looked at the max height of the shell. So what I'm showing here is a picture of that max height indicated by this axis, and I'm going to get ready to cut this shell, and I want to contain that max height in a cross section of the shell where the max height is kind of down the middle of that cross section. So I'm going to essentially cut kind of a thumb width size piece of this shell out. So I've marked kind of the edges with a Sharpie, the edges of where I'm going to cut, so that the max height ends up right in the middle of that cut section. What we're going to use to cut these shells is a water-cooled bandsaw. We have a Griffin brand bandsaw here. So we're going to walk through the process of kind of loading the water in and getting this ready to use. So the first thing we're going to do is pour water into the cavity below. There's a sponge down at the bottom. You'll want to put in enough water to kind of saturate that sponge. The saw blade is going to cross that sponge every time it makes a revolution. Additionally, there's a second sponge, a smaller sponge, up to the left here. You can kind of see it in this image with the yellow sponge. We're going to use the squirt bottle of DI water to wetten that sponge as well. Both of these will help keep that blade nice and cool as we cut the cross section of this shell. As we get ready to cut this shell, you'll see that we have these lines drawn to help guide our cutting. And we'll want to go right along those lines and make kind of two parallel cuts. Again, this cross section of the shell that contains the max height of the shell. And so we're going to move slowly to not heat this up too much. So we'll pass the shell through once, and then we'll remove the one part of the shell, and we'll go ahead and pass it through a second time to create this cross section of the shell, again, that contains the max height. As you're cutting these shells, you'll want to make sure that you have appropriate PPE on. So that includes a lab coat and safety goggles, and making sure that your fingers are out of the way of the sharp blade as you're cutting this shell. So in order to make this cross section where, like we said before, the maximum height is contained within it, we're going to make two cuts with this water-cooled band saw. So now we have three parts. The two outside edges, we'll want to make sure that the label has been transferred so that each of those parts is labeled. But those outer two parts we don't need at the moment, so we're going to put them back in the bag with the other valve, and we'll use those potentially at some point in the future. So the next step is to take that cross section that we've made, and we're going to embed it in epoxy. So we're going to have, in the end, we'll have 4 pours of epoxy, and that this image that I'm showing at first already had 1 pour done, and that was just to kind of coat the bottom. The next pour is going to happen after we place the shell cross sections on their side in the mold, as well as the label of the name of the shell. The epoxy that we use is a 2-part epoxy made by Buehler. We use the larger container that you see on the left and the smaller container on the right in a ratio of, by volume, of 4 parts to 1 part. If we're making a lot of epoxy as we're doing here, we have a kind of pre-measured out cup that we'll use, so we know how much epoxy and how much hardener to use. But regardless of how much epoxy we're going to make, it's in a 4-to-1 ratio. Whatever epoxy you use, please follow the directions given by the manufacturer. After you've mixed the two parts of the epoxy and stirred for the appropriate amount of time, given manufacturer directions, we're going to go ahead and pour this into the mold. And we're going to carefully pour it into the mold so that the label doesn't move around or the shell parts don't move around. And we're going to do just a thin layer here. This is the second pour. That first pour was allowed to dry. Then we place the shell cross sections and the labels, and now we're pouring the second pour here. So we're going to put the label face up in this second pour, and we'll allow it to dry based on the manufacturer's instructions. After the second pour has hardened, then we will go ahead and pour the third pour, which is just going to be epoxy. We'll allow that to harden. And the fourth pour then is where we're going to place another label, but this time, same name on the label, but we're going to place the label face down and pour that fourth pour. So that will take it to the top of the mold and completely encase the shell cross section in epoxy. After the fourth pour has been allowed to harden based on the manufacturer's directions, we're able to remove the epoxy and shells from that mold. So again, the way that we pour this epoxy was the first pour, which is just the base pour, nothing in it. The second pour, we had a label face up where we put the shells and those face up labels. The third pour was just a thin layer of epoxy, and the fourth pour then another thin layer of epoxy to take it to the top of the mold with labels in this fourth pour, but the labels are face down. Now we are ready to start cutting apart these shells and continuing the processing of these shells.